Hey guys, it's James from sportsdatamarket.io coming at you with another sports data analysis video. Today we're going to be using our NFL API to analyze the NFL draft. As part of our premium pricing tier for our NFL API, you get access to the NFL draft API, which goes back to 1985. And what we're going to be doing today is grouping the amount of first round draft picks by their respective universities. So I'm going to come over here, and this endpoint is what we're going to be using. We see that we can plug in a year parameter, and it'll give us data, the draft picks back for that respective year. And so using this endpoint, we're going to see how many first round draft picks came from each school. We're going to divide them up in intervals of 10 years. And this will give us some really cool insight into seeing which schools had the most talent attracted to them at that time, I should say. I think grouping it over the course of 40 years, we'll get to see that some of the schools that are pumping out a lot of first round draft picks right now maybe were not on top of the game 30 years ago, say, and vice versa. So without further ado, let's copy this endpoint. Let's jump over to VS Code and let's start analyzing. So I'm using Python today. And working out of a virtual environment. So you may need to either set up a virtual environment or pip install the request library to run this code. But I'm going to get started coding. The first thing I'm going to do is I'm just going to say var is equal to requests.get, and I'm going to punch in the endpoint that we just copied. And then I'll use the replace function here to substitute the year. So I'm going to replace the year. I'll replace the year with, say, 2022. It's a pretty recent year. And then on this next line, I'm just going to print out the JSON. And so this is, I'll call this draft data. A little more descriptive. And let's print out the JSON to see what we're working with. Okay, awesome. We see we get a lot of data back. This includes all the picks, inclusive all the way up to Mr. Irrelevant. And if we go up here to the first overall pick for 2022, it should be Travon Walker. We can see the next pick, Aiden Hutchinson, and so on. And so we can see that it's an object. We get back the year, space NFL draft as a key, and that key maps to a list of our NFL draft objects, which contain data such as the draft ID, year of the draft, round, pick, the team that selected the player, the player's name, the position they play, the college, and lots more information. From this information, the two keys we're going to be focusing on today are the round key, as this is going to tell us the round the player selected in. Remember, we're focusing on first round draft picks today. And then we're also going to focus on the college key, as we're going to kind of use this as a condition in the college key to map the college to the amount of first round draft picks they've had. So really quick, I'm just going to punch in, I'll say 2021 here. I just want to run this again to get back some data again, just so you can see that this key will change. So that says 2021 NFL draft here when we run this. So this key will say 2021 NFL draft. I just want to go over this so when we loop over this data, we can kind of understand the pattern and how we're going to index to get to access this list. Okay, cool. So that was just some upfront basic code I wanted to run so we kind of can visually see the data we're working with that comes back from the endpoint. Now I want to talk about like what I actually want to do with this little script here. So like I said, I want to group in intervals of 10 years going back to 1985. So we can think 85 to 95, 95 to 05, 05 to 15, 15 to present. In that fashion, I want to group draft picks, the first round draft picks, I should say. And I'm going to want to use a map so that I can map the school to the number of picks it's had. So yeah, that's kind of the logic we're going to want to write today. And so what I think I'm going to do as a first step is I'm going to kind of create a function signature. I think functionalizing this will make our lives really easy. And I'm going to call this function get draft list. and it's going to take in two parameters. The first parameter is a start year, and the second parameter I'm going to call end year. And if we can envision how I'm going to want to use this, because I'm going to want to call this function and say the start year will be like 85 or 1985, end year will be like 1995, right? Something like that. And so then in here, the first thing I'm going to want to do is I'm going to want to create a map. And this is the data structure that's going to be very important for keeping track of the schools and the respective counts. So I'm going to create just a map or a dictionary, call it college list. And then after this, I'm going to create a variable called current year. And I'm going to set it equal to our start year. Cool. So now thinking about what we want to do, right? This is basically going to be our start interval. And then we're going to want to start with an empty map. And by the end of the function, we're going to want to have this college list filled up with mappings of, say, like the school name, like something like the key of like Alabama to whatever the number, like whether it's 15 or whatever the number of first round draft picks, right? So we can imagine, well, college list will look something like this, like Alabama 15, Michigan, let's say like 10, right? Something like that. That's kind of what we want college list, I should say, to look like by the end of the video, or end of this function, I should say. That's what we want to return from this function. And so what I'm going to actually do is I'm going to create a while loop. I'm going to write a while loop. I'm going to say that our current year, while our current year is less than or equal to our end year, we're going to want to be looping, right? So this will allow us to have easy intervals of 10 years, right? So if we call this function with the start year of 2005 and an end year of 2015, right? We're going to start the logic at 2005. And while that is 2005 is less than or equal to 2015, say, that would be our end year in that case, right? We're going to perform logic where we're actually extracting data, etc. And so now in here, in this first line, this is where our data extraction is actually going to take place. So I'm going to create a variable called NFL draft data. And I'm going to set it equal to, it's going to be similar to our first line we had up here. It's going to be request.get, and it'll utilize this same endpoint, same kind of fashion. And we're going to want to do the same jargon where we replace with the year with the respective current year. With the current year. Cool. So this will give us back, remember, this type of data. So now we want to make sure that we index it properly. So the next line here, I'm going to extract the JSON. I'm going to say it, title is variable NFL draft JSON. I'm going to set it equal to NFL draft data.json. And then I'm going to call this variable index string. It's going to be the string we're going to use to index. And I'm going to set it equal to, I'll say, the casted string of the current year. Remember, this kind of goes back to indexing this key. So I'm going to say the casted string of the current year plus a space plus the word NFL draft. So this is our index string. And using that, our draft data is going to be our NFL draft JSON indexed with that index string. Okay, awesome. So that should get us this list. And now using that list, we're going to now want to loop over, pull out data, and add to our map. So I'm going to say for every object, that'll be looping over every one of these objects, draft objects, for every object in our draft data. I'm going to want to, remember, pull out two things. I'm going to want to pull out the round and the college, right? So I'm going to say round. Maybe a Python keyword. I'll say NFL round is equal to object round, and then I'm going to say college is equal to object of college. Cool. So these are the two variables we need. And this NFL round guy, his job is really to have a, we're gonna have a condition, right? Where if the NFL round is equal to 1, and it has to be equal to 1, because remember in this case we don't care about anyone who's not in the first round. So if our NFL round is equal to 1, this is where we want to add to our college list. So in here, I'm also going to have a condition. Since we're working with a dictionary, I'm going to have a condition where I say if the college variable is in our college list. In this case, we want to say college list of college, and we want to plus equal it to 1, so increment it. Now else, so if it is not in our college list, it means the first time we're seeing it. So I'm going to index college list of college, but I'm going to set it equal to 1. Cool. And then before we exit the while loop, so we don't run into an infinite loop, we want the current to increment our current year. Current year plus equals to 1. Cool. So this is the majority of the logic. And then right down here, the last thing we want to do is we can say return. Here's a little bit of a hard part. We're going to need to make use of the sorted function in Python. There's a little bit of Python magic right here, but we're going to want to return the dictionary, and we're going to want to use the dictionary of the sorted list. And we're going to pass in college list.items. So this is going to take our dictionary and create a list out of the key value pairs. And then we're going to utilize the lambda function so that we sort by the value item of item 1 rather than the key. We're sorting off of the value. And then we're going to say reverse equals to true. So what we did with this line right here is if we didn't have this line, our college list would be this blob, and we would just see a bunch of colleges mapped to their numbers. This line is going to sort them. So when we print out for an interval, we'll actually see we'll see this it's sorted by values. So I'll just run this right now so we can see it. I'm going to just say print get draft list of, let's say, 2005 to 2015. And assuming this doesn't have any errors, knock on wood, it should run clean. Awesome. Yeah, just printed out the JSON. Cool. So it's a little ugly right now. I'll run it again so we can see it in a cleaner fashion. But what we're going to see is a map, and you'll see that the leading key values have the most draft picks. So you can see Alabama leads everyone from 2005 to 2015 with 17 first-round draft picks. USC is number 2 with 16. Florida's followed by Florida State, 15, LSU, etc. So you can see this is just for one interval. We're almost done here. So what I want to do is I actually just want to make 4 different variables. And I'll say the draft data 1985 to 1995. And I'm going to set it equal just to get draft data of 1985 to 1995. Since it's inclusive, so this will be 85 to 95. The next variable I'll want to do 96 to 2005. 1996 to 2005. Down here I'll do 2006 to 2015. And down here, to finish it off, I'll do 2016 to 2024. That's the most recent draft. Awesome. Cool. And so let's just print these guys out, and I'll give them some space, and we'll see what we have. And so this is kind of nice, right? Because we're grouping these by periods of 10 years from 85, 95, etc. So this will kind of give us a way to see how talent in the college football landscape has changed from university to university over time. We'll be able to do that just by analyzing first-round draft picks put out by those respective universities. And I should say, as I'm doing this, right, there's something to be said about coaching certain programs. Just because a certain school doesn't pumps out the most draft picks, that doesn't necessarily mean they've won the most championships per se. With that said, there's probably a decently strong correlation, and we could probably see that. So right now I'm running it running it might just take a quick second to run over these data sets. And yeah, let's see what the results come back with. Awesome. So you see we have 4 different data sets, right? And so we can see what's pretty interesting. From 85 to 95, the leader was actually Florida, tied with University of Miami, tied with Tennessee, all tied for the lead. USC one behind. This is one of the most interesting observations. The largest discrepancy I see year to year, interval to interval. I just noticed a bug really quickly. We did everything correctly. I just noticed this last interval I punched in 2006. We want this to be 2016, right? Let's rerun this again. I just caught myself with a quick bug. With that said, we can kind of see what we got here, or we can see. So after rerunning this, we'll get back the correct data set for that last one. But we can see some of the mappings. What I was about to point out is from, I believe it's 96 to 2005, I think the biggest discrepancy was actually the University of Miami had more than double or nearly double. So our data just finished. This is what I was talking about right here. You can look at the discrepancies here. Alabama's out front. Here, Alabama's out front by a few. But during this period, the University of Miami nearly doubled up the next closest, Ohio State. As we go, we can see certain schools. Georgia's up here. We can write a little bit of logic. Actually, before I wrap this video up, something I want to do is I'm going to come down here and say var is equal to this. And what I want to do is actually write some logic here. I'm going to create a variable called return dict. And what I want to do here is actually just group by the top 5. So I'm actually just going to extract the schools that are only the top 5 in their respective draft intervals, I should say. After I run this code, I think it'll make more sense. But I want to see, so rather than focusing on schools that have like 1 first-round pick, I'm going to write some logic to say if a school has had more than 5, so if values more than 5, then let's append this to a return dict, or add it to a return dict. Return dict to key is equal to value, and then let's return the return dict here. And this will be the final time we'll run it. But what I wanted to do here is, so here we have kind of big data sets. All of these guys that have just 1 first-round draft picks, I kind of don't want to focus so much on them, right? So this condition I had, we're only going to add and return the guys that have schools that have more than 5 first-round draft picks in a particular period of 10 years. So this will just shave off a lot of the fat. We'll see, who are the powerhouses and kind of how they've changed hands. Yeah, so let's wait for the data to run. Awesome, awesome. So it's a little more clean, a lot less schools in here, and so we can really focus on the top heavy schools. An inference I make is just when you go back to the 80s and 90s, right? Like the talent discrepancy. Look at how many schools, like how even 13, 13, 13, 12, 12, 10, 10, 10. You know, you come down here, right? Like in modern day, like 30, 22, 18, 4. Like there's big gaps, down, the number, look at the top compared to the bottom. That's a difference of 24. Um, versus like in the 80s, top to the bottom, it was really only a difference of say 6 first round picks. That's a big difference in terms of talent. With that said, you can see the Miami really ran away with it, right? Like there's a lot of still, all of these are kind of nearby 14, 14, 11, 11, 10, 10, 9, 9. Miami just ran away with it during these years. So it's one of those things, like without even having to look at, who won national championships or whatnot, we can kind of infer that during this period in 96 to 05, Miami was doing pretty good. And then, yeah, we can see down here, Alabama's gets very rich, right? Down, especially in recent times, Ohio State, Georgia. Well, this is a bunch of analysis. I could go off all day on some of the cool things we see here. But this was a Python tutorial to analyze the NFL draft. And I hope you guys had a lot of fun and saw some cool things that you can do with our API at sportsdatamarket.io. I hope you guys tune in next time and continue coding around, hacking around with the API. Feel free to come over, make an account. It's completely free. You can tinker with the API. You get 75 calls free of charge. So thank you for tuning in, guys. I hope this was informative and gave a really, really cool glimpse into analyzing the NFL draft, I should say. So until next time, it's James from Sports Data Market. Thanks for watching, guys.